Hello, hello. In honor of the Denver Nuggets winning the chip, I decided, a month late, to do a little rudimentary, basic NBA playoffs data analysis. So I went to basketballreference.com and I pulled data from 2023 all the way back to 2017 NBA playoffs. And each team and each year is one row, so that's a total of 128 rows in our data set. Now, this is a very limited study. This is a very basic study. This is just kind of like, here's some interesting patterns that I found. It's not meant to be like going to the team's front office and being like, hey, here's what we need to do. It's just kind of like, kind of curiosity project on my part, and I decided to share with the world with the power of the internet. So, I'm going to briefly go through the data set, but before I do, I just want to say that this is a very limited study. And if you have any constructive criticism or destructive criticism or other feedback or ways I can improve or like steps to move forward, please drop a comment. I really like to hear from you guys. Okay, so I'm just going to go through this data set really briefly. So we have year, team, games, minutes played. Didn't really use these in any numerical analysis. And then all these .100s is per 100 possessions. I felt like that's the best way to have them by normalizing them. So field goals per 100 possessions, field goal attempts, field goal percentage, 3-pointers made per 100 possessions, 3-point attempts percentage, same with twos, free throws made per 100 possessions, free throws attempted per 100 possessions, free throw percentage, offensive rebounds, defensive rebounds, total rebounds, assists, steals, blocks, turnovers, personal fouls, points, average age, wins, losses, and win percentage. So win percentage is just wins divided by wins plus losses, and I decided to use that as my dependent variable, so that's what we'll be like trying to predict and measure. I couldn't really think of anything else. A better way to do this would be to go game by game and like pull some of the advanced game analytics and like try to predict whether or not an individual game would be won instead of looking at like a team's winning percentage. However, on basketballreference.com, there's like a website called StatHead, which is like a paid version, and that is all the advanced analytics I need, but I am a cheapskate, so I didn't buy it. So I just had to make do with what I had, and maybe I'll find some way to extract good NBA game data where I can predict individual outcomes of games as opposed to teams' winning percentage. Pythagorean wins, Pythagorean losses is just wins and losses predicted based on other metrics. I did not include these in the analysis. Offensive rating, defensive rating, and net rating. Felt like this is a combination of some other variables that are above or just strongly related. So I decided not to include those. Pace, which is possessions per 48 minutes. Free throws, free throw rate. So this is free throws attempted per field goal. 3-point attempt rate, which is the percent of field goals that are threes. Total shooting percentage, offensive effective field goal percentage, offensive turnover percentage, offensive rebound percentage, offensive free throws made per field goal attempt. So this is free throws made and this is free throws attempted. And then same thing with defense, except this is defensive rebounds. So the first thing I decided to look at was just kind of get a visual on the data. So I made these scatter plots. Now these scatter plots look super jank. And they look super jank because we're measuring win percentage. So like down here you have this horizontal line. That's teams that got swept. Here's win percentage of 0.2. That's teams that lost 1-4 in the first round. And then here's 0.33. That's teams that lost 2-4. So it just creates these janky scatter plots. So I'll just go through them just to show you. But then I have the correlations. And we can look at which variables are most strongly correlated as opposed to looking at these scatter plots. So you have pace, kind of even there. Field goal percentage, obviously a strong positive correlation there. Offensive rebounds, not really correlation. Defensive rebounds, however, very strong correlation. Assists, positive correlation as expected. Turnovers, not as strong of a negative correlation as I expected, but it's there. Personal fouls, a little stronger negative correlation. Points, obviously strong positive correlation. And 3-point attempt rate was just kind of all over the board. Which surprised me because 2017, I believe, was like either Durant on the Warriors or like the tail end of like the Warriors like destroying everybody, and that was when the three ball like really took off. And I don't know when like the Rockets were playing when they lived and died by the three, and they had that one playoff game against the Warriors that missed like 27 threes in a row. But I just thought like the league, since the Warriors started picking up, was moving more and more towards threes. So I thought I'd see like a little more correlation here. But you could also have the other side of, okay, teams just like chuck a bunch of threes and then they get down because they're like missing threes, and they are like, oh, we got to catch up, and they chuck more threes, and it's like a kind of a downward spiral there. So let's look at the actual correlation coefficients here, and the number and the magnitude are what's important. So pace is correlated, is pretty much no correlation there, negative 0.07. This kind of makes sense because all these teams have different play styles. Some teams like to go really fast, and other teams are more methodical, and it's just like based on the team. Field goal percentage, that's a really strong positive correlation, no surprise there. Offensive rebounds has no correlation, but defensive rebounds has a really strong correlation, which I guess just goes to show you that limiting the other team's second chance points is much more impactful than securing your own offensive rebounds. So that kind of surprised me because I figured since the NBA is more offensive leaning, getting an offensive rebound and like being able to put another shot up or like maybe get on the free throw line, it would be more important than the defense. But as you can see, like as you'll see later, defense wins championships. Assists, pretty strong correlation there. Turnovers and personal fouls, negative correlations. Not as strong as I thought, but yeah, personal fouls is stronger. I believe that's because you have players that get in foul trouble and then like they have to sit out. They have to play a little more careful defense because they don't want to get more fouls, and it just kind of messes with your rotation a little bit, especially in the playoffs when the rotations get a lot tighter. When your stars, getting 3 fouls in the first quarter, and then they have half their fouls are gone, and then they have to play 3 quarters of the game. So points is the strongest correlation at 0.53. Shocker, because that's how you win basketball, is you score more points. And then 3-point attempt rate. This is actually a positive correlation, but it's a relatively weak one. Moving on. So I decided to make it like a decision tree, which I'll show here in a second. But I wanted to look at if your win percentage was greater than half, which means if you won more than half your games in the playoffs, you had a positive record. And then if not, you had a negative record. And this left us with about 2-to-1 negatives versus positives. And I just wanted to look, this wasn't supposed to be a predictive model or anything. This is just okay, can I see what variables are important for positive win percentages? So we have defensive rebounds, important, offensive effective field goal percentage, and free throw percentage. So that all kind of makes sense. Some of those other metrics didn't really show up here, but this decision tree is not meant to be it's not meant to be taken anything more than just idle curiosity. This is a really sloppy way of doing it, and I just wanted to look and see what variables like this just showed up with just out of pure curiosity. Okay, so the actual analysis that I feel is the most useful is this linear regression that I did. So it's basically y equals mx plus b with a whole bunch of x's, and then your estimate is the slope, your m, and then the intercept is the b, but everything else down here is the m. And now the two things are important to pay attention to. This estimate column, which is the coefficient, the slope, and then this significance column. This is the t-test hypothesis level significance. And if you're not a stats person, you don't know a whole lot about statistical significance or hypothesis tests and stuff like that, you can just look down here, and just the more asterisks by a variable, the more significant it is. And then also, when we important caveat, when we look at these slopes, since the independent variables, are not 1-to-1, you can't really compare the magnitude of the slope. So, for example, field goal percentage is a number between 0 and 1, and then offensive rebounds, I don't know how many offensive rebounds a team gets in a game, 20, 30. I have no idea. I could be just out of my gourd on that. But even if it's as low as 10. It's still orders of magnitude higher than the free throw percentage, so you can't really compare the actual slope between the two, just because the magnitudes of the actual variables themselves are very different. Now, something you can do to kind of get around that is called logarithmic regression, I think. But basically, you take a log of all your x's, and then it kind of puts them, like, since the log makes them all really small, it kind of puts them on a more even playing field where you can compare the magnitude. But I didn't really want to look at the magnitude per se, because I just wanted to look at the direction here, is the positive and negative, and the significance level. And the reason I didn't want to compare the magnitude is because I just feel like the data is a little limited, and I just kind of wanted to keep it basic until I actually find some like good data, or like just basically some like better data, or like more rows or something like that, where it actually like doing a sort of like more advanced technique would be useful. So field goal percentage, significant, positive, no surprise there. Then we have, with threes, we have 3-point percentage not significant. 3-point attempts per 100 possessions is significant, but 3-point attempts rate, which is the percent of field goals that are threes, is significant, and it's negative. So that almost seems contradictory, right? I mean, the more 3-point attempts we have per 100 possessions, the more likely we are to win. Percentage isn't really significant, but if the more and more of our field goals that become threes, the more we have a chance to lose. And that's not a total contradiction, right? You can see the subtle difference, but it is just kind of crazy. And I was like mulling it over in my head, trying to figure out, okay, why could this be? There are two reasons that I kind of came up with in my head that are okay, but I don't know enough about like pro basketball to really know if these are actual good reasons or not. It's just what I thought of. So the first reason is maybe if a team gets down like a lot early, they might just try to jack up more threes because you're trying to catch back up sooner, and threes are worth more than twos, right? And then as you're trying to catch up, maybe you hit some, maybe you don't, and if you don't, you're going to just fall more and more behind, and like it's kind of a downward spiral there. Especially if a team lives and dies by the three, that could really, really impact the team's win percentage if they have a cold game or cold series. The other reason is I feel like since the Warriors obviously teams were shooting threes before, but the Warriors were super heavy on the threes and kind of changed the meta of the league a little bit. And I feel like teams are integrating the threes more and more into their game. And the teams that are better able to do that are taking more threes per 100 possessions, but not just turning all their field goals into threes. So that kind of is my explanation of why there's this apparent contradiction. Next, we have free throws and offensive rebounds, not significant. Defensive rebounds is significant. That kind of corroborates with our correlations from the scatter plots above. Assist pace and free throw per field goal, not significant. We looked at threes. Offensive effective field goal percentage is a little significant. And then all these defensive metrics are significant except for defensive rebounds, which we already had up here. So it's kind of conflicting there. So the analysis is going to pretty much ignore the second one. But I mean, this is kind of cool how all these defensive metrics light up as significant. And hey, I guess it just goes to show that defense wins championships. But this is just a basic data analysis of me just looking at stuff to fill my own curiosity. Don't go into league offices or take this as gospel or anything. The data I got isn't all that good. It's pretty limiting, and I just kind of I did a limited analysis on purpose, knowing I had data limitations. But I just kind of wanted to do this out of curiosity and kind of a passion project. And so I hope you guys found it interesting.